In statistics, the coverage probability of a technique for calculating a confidence interval is the proportion of the time that the interval contains the true value of interest. For example, suppose our interest is in the mean number of months that people with a particular type of cancer remain in remission following successful treatment with chemotherapy. The confidence interval aims to contain the unknown mean remission duration with a given probability. This is the confidence level, or confidence coefficient, of the constructed interval, which is effectively the nominal coverage probability of the procedure for constructing confidence intervals. The nominal coverage probability is often set at 0.95. The coverage probability is the actual probability that the interval contains the true mean remission duration in this example. If all assumptions used in deriving a confidence interval are met, the nominal coverage probability will equal the coverage probability, termed true, or actual, coverage probability for emphasis. If any assumptions are not met, the actual coverage probability could either be less than or greater than the nominal coverage probability. When the actual coverage probability is greater than the nominal coverage probability, the interval is termed conservative. If it is less than the nominal coverage probability, the interval is termed anti-conservative or permissive. Quote, "A discrepancy between the coverage probability and the nominal coverage probability frequently occurs when approximating a discrete distribution with a continuous one. The construction of binomial confidence intervals is a classic example where coverage probabilities rarely equal nominal levels. For the binomial case, several techniques for constructing intervals have been created. The Wilson score confidence interval is one well-known construction based on the normal distribution. Other constructions include the walled, exact, Agreste-Cool, and likelihood intervals. While the Wilson interval may not be the most conservative estimate, it produces average coverage probabilities that are equal to nominal levels while still producing a comparatively narrow confidence interval. The probability in coverage probability is interpreted with respect to a set of hypothetical repetitions of the entire data collection and analysis procedure. In these hypothetical repetitions, independent data sets following the same probability distribution as the actual data are considered, and a confidence interval is computed from each of these data sets. See naming construction. The coverage probability is the fraction of these computed confidence intervals that include the desired but unobservable parameter value. See also binomial proportion confidence interval, confidence distribution, false coverage rate, interval estimation.